Okay, this is right on the heels of our previous lesson, and we're going to prove lines parallel. Yesterday we talked about given that m is parallel to n, and we have our little parallel signs right here. Then we can conclude certain things about our angles, like for instance, our corresponding angles, like 1 and 5, are congruent, which leads us into the other theorems, because we can use vertical angles and supplemental linear pairs, to determine that our alternate interior angles are congruent, our exterior angles are congruent, and our same side interior add up to 180. All because we know that we are given parallel lines. Well, in this next example, we're not going to be given parallel lines, but we want to prove if these things are parallel. So we're going to be given an angle relationship. And here I have angles 1 and 5 are congruent. So here's 1 and here's 5. If they're congruent, they form the same shape. And the only way they can do that is if these two lines right here are parallel. So we can conclude that given 1 and 5 are congruent, then m and n are parallel. And you can visually see that. Like for instance, if I just notch this down a little bit, that angle right there is no longer looking in the same shape and form as this angle down here. The only way that can happen is if they're parallel. So here's our first example. Given measure of angle 1 is equal to measure of angle 9. I'm using measure because I was too lazy to write congruent. So here's 1 and here's 9. We first need to determine what transversal, let me repeat that, what transversal we're dealing with, m, and then what relation, what angle pair do they form? Sometimes they don't form angle pairs that we're familiar with. Well, these are corresponding angles, and the converse of our previous postulate. So we can say if corresponding angles are congruent, then lines are parallel. And here's our conclusion right here. And the lines that are parallel are the ones that cross this transversal, P and Q. These are parallel, so we can write a little parallel symbol right here. This is very important. Our conclusion is these two lines are parallel, and the reason, given corresponding angles are congruent, then lines are parallel. Have this well known. Next example. Given measure of angle 12 is equal to measure of angle 13. Well, let's find out where they're located. Well, here's 12. Here's 13. We're dealing with transversal Q's, so here's our transversal. All I did was just connect the dots right here. This is the transversal. Then we need to know our definition of what kind of angle pair this forms. Well, these are alternate interior. So these are alternate interior. And the affected lines are m and n. So given alternate interior angles are congruent, we're using the converse of that theorem from the previous chapter, then we can prove that m and n are parallel. And here we have it right here. M and M is parallel. The reason, given alternate interior angles are congruent, then lines are parallel. Look at that for a second. Look what we did. We first identified our transversal. Then we knew we were dealing with these two lines right here, whether they're parallel or not. And we were able to determine that because our alternate interior are congruent. So now we have another situation, 11 and 6. Well, let's find our angles. Here's 11, and where'd 6 go? Way over here. Okay. I need to identify the transversal. Yikes. There isn't one. There is no line connecting 11 and 6. Nothing. Well, that pretty much ends it. If there's no transversal, we can't prove lines parallel for anything. So my conclusion is straightforward. None. Reasons angle 11 and 6 do not form an angle pair. There is no transversal connecting them. This could be like whatever angle, this could be whatever angle. Don't go off the picture. The only thing you are given is this right here. I'm given that these two things are equal. I'm not given that other things are equal, or I'm going to assume it. I know that 6 can equal to 7, and 6 is supplemental to 5, and 6 is supplemental to 8. But that's as far as I can go. I can't even say that 6 and 14 are congruent, because that we can only say that if these two lines were parallel. So we're pretty much done. Our last example. We're given M is equal to, measure of angle M is equal to the measure of angle 16. So here's 16, and where's 5? So measure of angle 5 is equal to the measure of angle 16. Well, here's my transversal N. And that crosses these two lines, so these are the two lines in question. So I got to figure out, okay, what kind of relationship do these have? It looks like they're alternate exterior. And based on the converse of one of our theorems, if given alternate exterior angles are congruent, then we have parallel lines. And that's exactly what the conclusion I have. And those parallel lines are P and Q. These lines right here, because this is my transversal. This line M has nothing to do with the problem. It could disappear for all I care. You can just slice it out. Because nothing is touching it. We're not talking about it. M, who cares? All right, so that's it for proving lines parallel. You need to refresh this and think about these definitions.